Hi everyone, this is the third of 3 videos for the solutions to the 2021 Hsc Maths Advanced exam. In this video we're going to look at the solutions to Booklet 2. Question 29. On the day that Megan was born, her grandfather deposited $5,000 into an account earning 3% per annum compounded annually. Each birthday after this he deposits $1,000 into the same account, making the final deposit on Megan's 17th birthday, that is a total of 18 deposits are made. Let A subscript n be the amount in the account on Megan's nth birthday after the deposit is made. Show that A3 is $8,554.54. Right, so A0 is the day that she is born and 5,000 is deposited. A1, so when she turns 1, we're going to take our A0, which is 5,000, give it some interest, and then we're going to add $1,000 to it. Now normally we would set up a pattern here. But if you've read through, part B is actually nothing to do with this. I'm actually going to work this out. 5,000 times 1.03 plus 1,000 is equal to 6,150. A2, we're going to take A1, which is 6,150, give it some interest, and add on $1,000. Still got it in my calculator, so times 1.03 plus 1,000. Is $7,334.50. And then finally A3, take A2, give it some interest, add on 1,000, and hopefully we get the answer we're looking for. So times 1.03 plus 1,000, yes we do, $8,554.54. On her 17th birthday, just after the final deposit is made, Megan has, so this is A17, $30,025.83. You're not required to show this. She then decides to leave all the money in the same account, continuing to earn interest at 3% per annum, compounded annually. On her 18th birthday, so 1 year later, and on each birthday after this, Megan withdraws $2,000 from the account. How many withdrawals of $2,000 will she be able to make? Right, I'm actually going to restart this and call this A0 because we've got a new pattern here with these withdrawals. So A0 is $30,025.83. A1, 18th birthday. Take the money she has, give it some interest, and then withdraw $2,000. Now I'm not going to work this out because we need to work out what the pattern is. A2 will be whatever A1 was, multiplied by 1.03, take away 2,000, is $30,025.83 times 1.03, take 2,000, times 1.03, take 2,000. So A2 is equal to, let's just expand that out, 30,025.83 times 1.03 squared, take 2,000 times 1.03, take 2,000. And I'm just going to factorize that last little bit so that we can see what the pattern is. So let's predict what AN is. It's going to be 30,025.83 times 1.03 to the power of n, take away 2,000, 1.03 n minus 1 plus 1.03 then minus 2 plus dot 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 plus 1. So what we want to do is work out how many withdrawals she can make. So when is this balance going to equal 0? All right, let's tidy this up. $30,025.83 times 1.03 to the power of n equals 2,000. And I'm going to turn these terms around so it's easier to sum. All right, we have a geometric progression here. A is equal to 1, R is equal to 1.03, and n is equal to n. So $30,025.83 times 1.03 to the power of n equals 2,000 times A. R to the n minus 1 all over 1.03 minus 1. All right, I'm going to work this part out here. 1 divided by 1.03, take away 1. And that's actually equal to 100 on 3. So let's tidy this up. $30,025.83 times 1.03 to the n is equal to 2,000 times 100 on 3 times 1.03 to the n minus 1. And that is going to be equal to 200,000 on 3, 1.03 to the n minus 1. Equals 200,000 on 3 times 1.03, take away 200,000 on 3. Now when you have an equation that has two terms in 1.03 to the power of n, you need to get them together. So what I'm going to do is take this over here and join that together, and then this one over here, like this. So we have 200,000 on 3 is equal to 200,000 on 3, take away 30,025.83, lots of 1.03 to the power of n. Okay, let's work out 2, 3, 4, 5, 6, what this number in the brackets is. 200,000 divided by 3, take away 30025.83 is 36640. 36640.83667 times 1.03 to the power of n. Now I'm going to take this number here over the other side and divide by it. So divide by 36640.83667. Right, on our calculator, we've got 200,000 divided by 3 divided by that number. I have 1.03 to the power of n equal to 1.81946. All right, let's do some logs. Ln 1.03 to the n equals ln 1.81946. Bring the n down. N ln 1.03 equals ln 1.81946. Divide both sides by ln 1.03. And we will get our answer. Let's look at that in the calculator. So ln ants divided by ln 1.03 bracket 20.25. Now it says how many withdrawals of $2,000 will Megan be able to make? The money's going to run out after 22.25 years. So she can make 20 full withdrawals. Question 30. The number of hours for which light bulbs will work before failing can be modelled by the random variable x with cumulative distribution function as shown. Jane sells light bulbs and promises they will work for longer than exactly 99% of all light bulbs. Find how long, according to Jane's promise, a light bulb bought from her should work. Give your answer in hours rounded to 2 decimal places. Now, we're going to need to work out the 99th percentile. And remember, we do this by working out the integral from 0 up to x of lowercase f of x dx. And that's equal to this. And we've already got this. All right, so this is actually going to be equal to 1 take away e to the negative 0.01x. So all we need to do is solve this equation. 1 minus e to the negative 0.01x is equal to 0.99. All right, 1 take away 0.99 is equal to e to the negative 0.01x. So 0.01 equals e to the negative 0.01. We're going to do some logs again. Ln 0.01 is equal to ln of this side. That will cancel out to negative 0.01x. X equals ln 0.01 divided by negative 0.01, which is, let's see, ln 0.01 brackets divided by negative 0.01 is 460.5. We want it to 2 decimal places. 460.52 hours. Question 31. By considering the equation of the tangent to y is equal to x squared minus 1 at the point a squared minus 1, find the equations of the two tangents to that curve which pass through the point 3, negative 8. Right, let's start with the gradient of the tangent y dashed is equal to 2x. And we want it at the point x is equal to a. So the gradient will be 2a. So let's just find this general equation of the tangent. So y take away, don't forget your brackets, a squared minus 1 is equal to 2a x minus a. And tidying it up, y is equal to 2ax minus 2a squared plus a squared is minus a squared minus 1. Right, we're going to substitute this point in and solve for a. So negative 8 is equal to 2a times 3 minus a squared minus 1. Negative 8 equals 6a minus a squared minus 1. A squared minus 6a minus 7 is equal to 0. And we can see that there are two values. And just factorising this, negative 7 plus 1, a is equal to negative 1 or 7. We want to find the equations of both of them, so we need to substitute those in. So when a is equal to negative 1, we're going to get y is equal to negative 2x minus 1 is minus 2. And when a is equal to 7, we are going to get y is equal to 14x minus 49 minus 1 minus 50. And there's the two answers. Question 32. In a particular city, the heights of adult females and heights of adult males are each normally distributed. The information relating to females from that city is given in Table 1. The means and standard deviations of females and males in centimetres given in Table 2. A selected male is taller than 84% of the population of adult males. By first labelling the normal distribution curve below, with the heights of the two females given in Table 1, calculate the height of the selected male. All right, tricky question, mainly because we're not given an actual mean or standard deviation. But we'll do what they say. First label the normal distribution curve with the heights of the two females. Now, this is going to be about the empirical rule. So we come up here, we don't know what the mean is, so that's just mu. This is mu plus sigma, and mu plus 2 sigma, etc. Our first female is at the 97.5 percentile. Now we know that in between here, between negative 2 and positive 2 standard deviations, we have 95%. The whole thing's 100, so there's 2.5% here. And there's 2.5% here. And so to get 97.5, we want all of that 95 plus this 2.5. So our first female is here. And I'm just going to erase that and write in that value, which is 175. Okay, let's get rid of all of this and now work out the second female. And we're going to use the percentage that's in between one standard deviation from the mean, which is this one here. So this part here is 68%, which makes this bit 34. And if we do 50, which is all of this half, take away the 34, in there we're going to get 16%, which means that our second female is sitting here. All right, again, we're going to erase this one, and this is where female 2 is. 160.6 centimetres. All right, now finally, the male. Now, what is their number? 84%. Okay, so that's going to be above the mean, because to this point it's 50%. We've got 68% again. 34% in there. So 50 plus 34 is 84%. So the male is sitting there. Okay, now we need to work out the height of the male. And pretty much the only way to do that is to use these two values here, solve simultaneously to work out the mean and the standard deviation, and then use that to work out the height of the male. All right, so starting with this female here, this is mu take away sigma is equal to 160.6. And then the other female, mu plus 2 times sigma is equal to 175. And I'm going to do equation 2, take away equation 1. So mu take away mu, that's gone. 2 sigma take away negative sigma is 3 sigma. 175 take away 160.6. 175 take away 160.6 is 14.4. Divide both sides by 3. 4.8. And then substitute into equation 1 gives us mu take away 4.8 equals 160.6. Mu will equal 160.6, 165.4. Okay, and now the male. Their height is going to be their mean, which is 1.05 lots of the female mean, plus 1 lot of their standard deviation, and their standard deviation is 1.1 times the female standard deviation. And just putting that into the calculator, 1.05 times 165.4 plus 1.1 times 4.8 gives us to 2 decimal places 178.95 centimetres. Question 33. People are given a maximum of 6 hours to complete a puzzle. The time spent on the puzzle in hours can be modelled using the continuous random variable x, which has probability density function as given. The graph of the probability density function is shown below. The graph has a local maximum. Show that A, which is up here, is equal to 2 over log 10. So remember, for it to be a valid probability density function, the area under the curve has to equal 1. So we're just going to do that. Between 0 and 6 of ax over x squared plus 4 dx has to equal 1. All right, I'm going to throw this a out the front just to make life a little bit easier. And this is a reverse chain rule. It's one of those ugly ones. I'm going to adjust it. I don't know if you do it this way, but when I come to doing the derivative of this denominator, I'm going to need a 2x. So I'm going to put a 2x there, and I'm going to adjust it here like that. All right, we're ready to go. A over 2. We're integrating this. So this is a log of x squared plus 4. If you're unsure how to do that, go and do some practice on it. I've actually got a video on that on the reverse chain rule, so you might want to have a look at it. A over 2 ln 6 squared is 36 plus 4 is 40. Take away ln 4. I don't really need those absolute values anymore, but never mind. Okay, taking this 2 over the other side, and I'm also going to do this. 40 take away log 4, and using our second log law, when I subtract logs with the same base, I can divide those arguments. So this is 2 over ln 10. Done. Part B, show that the mode of x is 2 hours. So remember, the mode occurs at the highest point, which in this case is this maximum. To find that, we're going to take the function and differentiate it and put it equal to 0, because the gradient of the tangent there is 0. So we want the derivative of ax over x squared plus 4. All right, I'm going to throw this a out the front. It is 2 over ln 10. And then I want the derivative of x over x squared plus 4, which is a quotient rule. So let u equal x and v equal x squared plus 4. U dashed is equal to 1. V dashed is equal to 2x. So this is equal to 2 over ln 10. V which is x squared plus 4, don't forget your brackets, times du dx minus u times dv dx all over v squared. That's a 4 there. And I want to put all of this equal to 0. Okay, firstly, we can divide both sides by this 2 on log 10, that's going to go. And we only want to solve this numerator because there is no circumstance where the denominator can equal 0. So that simplified things a bit. 2 bracket x squared plus 4, take away 4x squared is equal to 0. 2x squared plus 8 minus 4x squared is equal to 0. 8 take away 2x squared is equal to 0. That equals 2x squared, divide both sides by 2. 4 is equal to x squared. X is equal to plus or minus 2. Now obviously this is going to be a positive value, so we can disregard the negative value. The mode is 2. C, show that the probability that x is less than 2 is equal to log base 10 of 2. So this was 2 here. We want this probability, which is the area under the curve between 0 and 2. So set up the integral. A is 2 on log ln 10. I'm going to put it out the front. And I've got x over x squared plus 4 dx. Actually, I'm going to change my mind. I'm going to borrow that 2 and put it back in here because I need it. Equals 1 on ln 10. Integrate ln x squared plus 4. Between 0 and 2, substitute in 1 on ln 10. Ln 8, take away ln 4, equals 1 on ln 10 times ln 8 over 4, which is log 2. So we end up with ln 2 over ln 10. Now, this is the change of base rule, and we're changing to base e. So I can easily put it back into base 10 like this. Now, if that doesn't make sense for you, just do it backwards. Suppose you want to change this into base e. Then we would do ln 2 over ln 10, wouldn't we? So that's how they've got from there into there. I guess you could change the base on both of these to log base 10 and you would end up there as well. But it's pretty easy just to do it straight through like that. D. The intelligence quotient IQ scores of people are normally distributed with a mean of 100 and standard deviation of 15. It has been observed that the puzzle is generally completed more quickly by people with a high IQ. It is known that 80% of people with an IQ greater than 130 complete the puzzle in less than 2 hours. A person chosen at random can complete the puzzle in less than 2 hours. What is the probability this person has an IQ greater than 130? Give your answer correct to 3 decimal places. So we've got a bit of probability here, conditional probability, would you believe, as well as some normal distribution. So we want the probability that this person has an IQ greater than 130 given they completed the puzzle in less than 2 hours. So IQ greater than 130 given they complete the puzzle in less than 2 hours. Now, using our formula, this means probably that their IQ is greater than 130 and they complete it in less than 2 hours, divided by the probability that they completed it in less than 2 hours. Now, if you can manage to get that far, the rest is not too bad. We want to work out the probability that a particular person has an IQ greater than 130 and they complete the puzzle in less than 2 hours. Now we know this bit, 80% of people with an IQ greater than 130 complete it in less than 2 hours. So that bit there is 80%. This is the probability that any particular person completes it in less than 2 hours, which we just worked out. It was log base 10 of 2. So what's the probability that any person has an IQ greater than 130? We need to go to our normal distribution curve, figure out where that is. So just drawing that up, we know we have got a mean of 100. Adding on a standard deviation gives us 115, and another standard deviation gives us 130. So this is the 90 7.5 percentile. We worked that out in a previous question. So the probability that they have an IQ above that is 2.5%. And the probability that this particular person completes it in less than 2 hours is 80%. And the probability that anybody completes it in less than 2 hours is log base 10 of 2. And putting that in the calculator, we get 0.0664, and they wanted it to 3 decimal places, so 0.066. Okay, last question. A discrete random variable has a probability distribution as shown in the table where n is a finite positive integer. Show that e of x, the expected value of x, is n multiplied by 2r minus 1. So remember that the expected value is given by this formula. Sigma x times p of x. And we multiply, we go this times this, plus this times this, plus this times this, etc., etc. So let's write this down. It's equal to r times r to the n plus r squared times r to the n minus 1 plus r cubed times r to the n minus 2 plus, I'm going to skip that middle one, plus r to the n times r, which is equal to r to the n plus 1 plus r to the 2 plus n minus 1, which is n plus 1, plus r to the 3 plus n minus 2, which is n plus 1, I'm seeing the pattern, plus r to the n plus 1. And how many of those do we have? You look through here, this is 1 through to n, there are n of them. So I've got r to the n plus 1 times n. And I can see that it's sort of what we want, but not quite. So how do we get there? Well, there's something else that we know about probability distribution functions, and that is that all the probabilities have to add up to 1. So r to the n plus r to the n minus 1 plus r to the n minus 2 plus dot 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 plus r must equal 1. All right, let's sum this and see if we can figure out an expression, an alternate expression for r to the n plus 1. I'm just going to turn it around. R plus r squared plus dot 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 plus r to the n is equal to 1. In this case, a is equal to r is equal to r, and n is equal to n. Okay, so using our formula, a is equal to r is equal to r minus 1 is equal to 1. All right, r times r to the n minus 1 is equal to r minus 1. Expand, r to the n plus 1 minus r equals r minus 1. R to the n plus 1 is equal to 2r minus 1. There we go. And so we had this here. This is going to be equal to n multiplied by 2r in brackets, 2r minus 1 in brackets.